Hello, good day. My name is Mr. McCroy. Today we shall be looking at a topic in chemistry, atoms. Yeah, I put up this video because so many science students have one or two issues with understanding atoms in chemistry. Now, what's an atom? An atom is the smallest particle of an element that still retains the chemical properties of that element. So if you get an element, you break it down. The smallest particle of the element that still retains the chemical property of that element, that is what an atom is. So know this as a definition of atom. You can represent atom of different elements with their formulas. For instance, atom of sodium is Na. Atom of magnesium, Mg. Atom of hydrogen is H. Concerning the theories and models of atoms, different scientists have made several postulations or models or theories as to how an atom looks or what an atom actually is. One of the foremost scientists is John Dalton. John Dalton made some theories about atoms, although some of them have been disproved today, but they're still relevant. One of them is that atoms are the smallest indivisible part of an element. That theory was disproved, but because atoms are not indivisible. That's one of them. The second theory he made was that atoms of the same element are identical in all aspects. And the third he made was when atoms combine, they do so in simple whole number ratio and all of that. So, according to John Dalton, atoms cannot be broken down. All right? That is why his theory was disproved, because atoms can actually be broken down. Another person that made theories about atoms is J.J. Thomson. J.J. Thomson. J.J. Thomson's model of an atom is that an atom is made up of a positive sphere, a positively charged sphere that has electrons implanted in it. So it's a positive sphere with electrons inside it like this. Yeah, J.J. Thomson was right because he was the person who discovered electrons. He discovered electrons. And that was why he was right. But concerning his model of atom, he was wrong, because this is not how an atom looks. An atom does not have positive and negative charges all arranged like this. So that was why his model of an atom was wrong. Ernest Rutherford was the person who actually gave the right model as to how an atom looks. According to Ernest Rutherford, an atom is made up of a positively charged nucleus. Yeah, a central part that is positively charged with electrons moving around it. Like electron moving around the nucleus, like this. So, Ernest Rutherford postulated that atoms are made up of positively charged sphere, that's the nucleus, inside, with electrons moving around it. So today, we see atoms as this. This is the correct structure of an atom. There is a positively charged internal part called the nucleus, and electrons moving around it like this. Yeah, in orbitals. These electrons are located in orbitals moving around this electron. So we shall be looking at the structure of an atom. Basically, an atom is made up of three subatomic particles, which are proton, neutron, and electron. Proton is positively charged. Neutron is neutral, that is, has no charge. And electrons are negative. All right? So the proton and the neutron, they are both inside the nucleus. Proton and neutron are inside the nucleus, while the electrons move around it. And at every point in time, the number of protons and number of electrons must be equal in an atom. That is why an atom is electrically neutral, because proton equals electron. That means the positive charge, let's say there are 11 positive charge, 11 protons, 11 positive, equal to the 11 electrons, 11 negative. they will both cancel themselves, making an atom to be neutral. All right? So, please take note that the number of proton plus neutron will give you the atomic mass. Atomic mass of an atom. Number of proton plus number of neutron is the atomic mass. There is something called atomic number. Atomic number is simply defined as the number of protons in the nucleus of an atom. That is atomic number. Okay. Now, there is a huge difference between an atom and an ion. Yes. And the difference is this. An atom has equal number of protons and equal number of electrons. An ion doesn't have equal number of protons and electrons. So basically, what is an ion? An ion is an atom that has lost or gained, that has gained or lost electron. An ion is an atom that has gained or lost electron. Let's look at oxygen, for instance. This is oxygen. Let's draw the structure of oxygen. Oxygen has atomic number of 8. So it has 8 protons and 8 electrons. So this is it. 1, 2, 3, 4, 5, 6, 7, 8. This is oxygen. Oxygen would like to complete its outermost shell because normally the first shell has 2 electrons inside it and the other ones have 8, 8, 8, and so on. That's the arrangement of electrons in the shell. So oxygen needs extra 2 to complete this shell. Now what oxygen is going to do is that it's most likely going to receive 2 electrons to become this. Now it has received 2. These are the 2 electrons received by oxygen. Let's analyze it. Here, oxygen has number of protons in oxygen is 8. 8 positively charged. And number of electrons is also 8. 8 negative charge or 8 negative charges. So it cancels out, making this neutral. Now, in the ion, number of protons does not change. It remains 8 positive charges. But the number of electrons have increased. They are now 10 because 2 extra were added. So for electrons, they are 10 negative charges. Now when they cancel out, you have 2 negative charges left. That is why this is written as O2 minus. 2 minus, meaning 2 negative charges. So basically when you want to write an ion, if it is receiving electron, it becomes negative. If it is giving out, it becomes positive. Just write the number of electrons it has received or gained and the charge involved, right? So let's give another example. Let's say sodium. This is sodium. Sodium has atomic number of 11. So it has 1 outside. This is sodium atom. When it becomes, this is sodium atom. When it becomes an ion, it becomes like this. So sodium has given out this 1 electron outside. In a bid to complete its outermost shell, it can either gain 7 to make this 8 or give out this 1. And the easier one is to give out this 1. So sodium will give out 1 and become N. So making this to become Na+. It is positive because it has given out electron, and that's +1, meaning it has given out just 1 electron. Okay. Having taken note of that, remember I said that an atom is made up of 3 subatomic particles, which are proton, neutron, and electron. There is a phenomenon in science you call isotopy. Isotopy. What is that? It's simply when 2 atoms have the same atomic number but different atomic mass. They have the same atomic number but different atomic mass. Okay, so look at chlorine, for instance. You have chlorine and chlorine. There is chlorine that has atomic number 17, masses 35 and 37. So looking at this, they have the same atomic numbers but different mass numbers. And that's why they are called isotopes. This phenomenon is called isotopy. they are called isotopes, all right? The reason why isotopes exist is because of difference in number of neutrons. So it is because of difference in number of neutrons. For instance, this one has 17 protons, 17 electrons, but for neutron it has 18. For this other one, the same thing, 17 protons, 17 electrons, but for neutron it has 20. And remember that proton plus neutron is what gives you atomic mass. Proton plus neutron, 35. Proton plus neutron, 37. Now, there is a way to calculate the relative atomic mass of this using their percentages, all right? Now, please take note that although these two atoms, they are isotopes, that means they have the same atomic number but different mass numbers, but they have the same chemical properties. Isotopes have the same chemical properties because chemical properties are now affected by neutron. They have the same chemical properties, all right? But they may have different physical properties, but they have the same chemical properties. So, in the next video, we'll look at isotopy, how to calculate for relative atomic mass of atoms, and so many other things about atoms. Until then, see you.